This is lecture 5, example 2. This is going to be an example of a case statement, and so let's get to it. What this program's doing is it's a subroutine, and essentially it's going to look at the value in register x20. So if the value equals 64, it's going to divide it by the value by 8. If the value equals 128, it's going to divide it by 32. Otherwise, it's just going to clear the value. So be the good programmer here. We're going to start off with a flowchart. So we'll do this. We'll just call it case. And so first thing I'm going to do is say val equals what, 64. There's my no. There's my yes. If it equals 64, I'm going to divide by 8. Okay, so if it no, I'm going to say is the value equal to 128. Here's my yes. In that case, I'm going to divide by 32. And if this is a no, then I'm going to clear. What is it, x20? And then I'm going to return. And so these two cases here, these are the cases where it tests true. I'm going to do what it needs to, and then I'm going to return. So these, if you notice, this return has 3 exit statements, and that's okay. You know, you can have as many paths to the return as you need to. So let's do this thing. We'll call it, I don't know what to call it. Case. Probably not a good word. Case construct. Okay, so, and then I'm going to initialize. I'm going to always put this in here out of habit. There's really nothing to initialize in this thing. So the very first thing I have to do is to check to see if it's equal to 64. So I'm going to do that, but I need to be able to compare it to 64, and what you'll find is you can only compare registers. And so the very first thing I need to do in this problem, in this program, I think I'm going to move that over a little bit, is to put the value in a register. Load immediate. Doesn't matter where I put x30. And what do we want to compare it to? 64. Okay, so in that case, what I'm going to do here next is have a branch statement, and this is going to be branch if not equal. And that's what I'm going to do, is compare these two values, x20 and x30. Okay, so I stuck x20 and x34. I'm sorry, I stuck 64 and x30, so it's comparing the value in x20, which you can't read there, to x30. And so if it's not equal, I'm jumping somewhere else. And I'm going to jump to, I'll just make something up, check 128. Sounds good. Okay, so, and I'll come down here and put that down there. That's just going to be a label, check 128. And we'll worry about that later, but what I want to do in this program here is if it's not equal, it jumps, but if it is equal, it has to do this instruction, or this operation right here, which is divide by 8. So once again, there's no divide and multiply instructions, but we do have shift left and shift right, and so this is very conveniently dividing by a power of 2, so all I have to do is shift. What am I shifting right on this thing? So this is going to be divide by 2. Look at the shift right, logical immediate. I'm shifting x20 by essentially 8. So the shift value is 3. So if you look at this thing, this is actually a barrel shift, and I'm shifting x20 3 to the right. Okay, this is immediate value. Once again, I'm shifting x23 to the right, storing the result in x20. And once I do that, I can call myself done. And so, generally speaking, I have a done label down here, which I need to jump to, which is going to have the return statement. Okay, so that means it's either going to jump, this is going to test true, and it's going to jump down here, or it is true, it is equal, and it's going to do the divide. So once I have that, this is a classic, if then else structure. What I'm going to do here is do another if then else structure, but I'm going to read up in this thing, and I'm going to essentially copy this thing with new numbers. So this is a load immediate instruction. It's loading 128 to x30. This is another branch if not equal. I'm going to do the exact same thing, x20, x30, and I'm going to jump to what am I going to jump to? I'm going to jump to, we'll just call it default, following a C convention here. Default. And so if those are not equal, if x20 is not equal to 128, it jumps down here, and I'll worry about that in a second. But if it is equal to it, I'm going to do a divide by 32, which is once again a shift left immediate, x20, x20, this time 32 is 2 to the 5th. It's a shift right immediate 5 places. And that's 5. This shift right logical immediate instruction, once again it shifts it 5 places to the right, which is equivalent to a divide by 32. And then once again, copying this, I can jump to done. Okay, so if these two cases, essentially these are two cases here. This is one case, this is the other case. If these fail, I've got to clear x20, which is essentially a move instruction, and so I can move x0 into x20, and then it falls down to this instruction. So once again, if you look at the structure of this thing, it is like an if else, and follow this is essentially, I guess, a sequence statement. So there's two if else there's. Quite boring as it is, but the issue in this thing is this code here implements this flowchart here. Now I'm not going to look at, one of the things you'll find out with assembly language is there's many ways to do everything in assembly language. There's nothing magical about the way I did this. You could have done this with BEQs or branch of equals statements as well. This is the approach that made the most sense to me. And what I did on this instruction was I knew I needed to do some type of checking on it, and so I just looked at my cheat sheet. Branch not equal seemed the most intelligent to me at the time. So the other issue to realize in this thing is division by powers of 2, multiplication by powers of 2, or shift left and shift rights. These are essentially barrel shifts. I'm essentially shifts this many places. You can see like 2 to the 5th is 32, 2 to the 3rd is 3, and then I jump to where I need to jump in these things. And I'm going to go ahead and call this instruction done. And once again, I never use the init label. It's more of a comment. This is an important label we'll get to later. It is a subroutine, so it does need a return. And I think that is done. So, one other comment on this thing is you're going to develop your own style in solving these problems. Kind of my own personal style is anytime and you saw it here, anytime I see a label, anytime I put a label in a statement, I go put that label in the program somewhere so I don't forget about it. So these two branch statements needed labels to jump to. I'll same with these unconditional branches, and that's what, like I said, I put the label down and I go fill in the code later. Remember that the labels are places to jump to for humans to understand. The assembler is going to fill in all the details and make all the right jumps happen, as we detailed in the program counter, which we talked about before. So once again, the structure of this thing is kind of an if-else and an if-else followed by just a sequence statement.